Hello everybody, I would like to talk about the Pearson's correlation coefficient. In a previous presentation, I talked about the main concepts for the correlation. I have talked about the direction of the correlation and the strength of the correlation, and I talked about the scatter plot for the observation. You can simply turn back to it. First of all, the definition of the Pearson correlation coefficient, which is abbreviated by small r. It is simply a measure for two things. First, it is a measure for the strength and the direction of a linear relationship between two variables x and y. And of course, one of the two variables is considered as the independent variable, and the other is called the dependent variable. Before starting the calculations related to the Pearson correlation coefficient, it is better to draw the scatter plot for the observation in the coordinate, just to have a general idea regarding the direction and the strength of the observations. For example, what we have here, the scatter plot drawn in this graph, simply represent, let's say, a negative direction for the correlation. Let's make a review regarding the strength and the direction of the correlation and talk about the Pearson correlation. In this figure, we have a full or the correlation of the observations here between x and y is complete. So it is considered as a strong negative correlation. It is negative correlation simply because the direction of the points as the value of x increases, the value of y decrease, and simply we can join all the points in one simple straight line. So in this case, we have strong negative correlation, and the value of the correlation here is considered -1. On the opposite side, here we have a strong positive correlation, simply because as the value of x increases, the value of y also increases. And it is considered to be complete correlation because all the points, we can join all of these points in one single straight line. So in this case, we consider that the correlation between the two variables is complete and it is +1. So in general, the value of the correlation coefficient lies between -1 and +1. Sometimes we conclude that there is no relationship between the two variables. So in this case, we have no correlation. And in this case, the value of the correlation coefficient is 0. And sometimes we have, let's say, a moderate correlation, whether it is positive, same like what we have here. Here we have a weak positive correlation, and the value of the correlation here is 0.5, and it is positive. On the other side, we have here a weak negative correlation, and the value of the correlation coefficient is minus 0.5. So this is a quick review regarding the direction and regarding the strength of the correlation between two variables. First of all, before starting the calculation for the correlation between two variables, we should notice whether there is something called outlier point, same like what we have here. See that the point P in this figure, somehow it is not consistent with the other points or the other observations. So this point will affect significantly the correlation coefficient R. The purpose of having such outlier point, sometimes we have what's called the random error. Sometimes the person who is performing the experiment, sometimes he has a lack of skills. Sometimes he has a lack of skills in using the instrument or the tools for the experiment. Sometimes the environment that the experiment is performed, sometimes something wrong. So simply we can obsolete this point and complete the calculation for the rest observations. Let's understand more about the outlier point. For example, here the point P is not an outlier. It is a consistent point, same like the other observations. So the coefficient, the correlation coefficient small r is 0.88. So we have a strong positive correlation between X and Y. See in this figure, the point B is somehow, it becomes extreme point or outlier point. So the coefficient becomes, instead of becomes positive, it becomes negative, and the strength becomes very weak. So in this case, the value of R is minus 0.08. So this is the effect of having an outlier point. We have two formulas in order to compute for the correlation coefficient or Pearson coefficient, small r. The first one in the top. If you are using an Excel, you can simply use this formula and calculate the R directly. The other formula below here depends on the calculation of the average for X and the average of Y. So you can use the top formula or the lower one. Of course, you should get the same results. Let's solve this question by using the two formulas separately. The question here is saying to compute the correlation coefficient small r for the following data. And once you get this value, interpret your results. So we have 7 observations, and we have the records for both X and Y for each observation. As I have mentioned, it is good to draw the scatter plot for the observation in order to have a general idea regarding the correlation between the two variables. So by looking at the scatter plot here, we conclude that we have a negative correlation between the two variables X and Y. So let's start using the first formula. These are the observations for both X and Y. First of all, we need to sum up both X and Y. So the sum of x is 36, while for y it's 44. Then we compute x square and sum up. So we should add a new column here for x square. So for this value of x1, the square of 1 is 1. For the second x, which is 10, the square of 10 is 100, etc. And the summation of x squared is 256. Compute y square and sum up. So we add a new column here for the y square. For the first observation of y, it's 8. So the square of 8 is simply 64, etc. And the summation of the y square is 300. Compute xy and sum up. So for each observation, we should multiply the value of x by the value of y. So we add this column here. For the first observation, x is equal to 1, while y is equal to 8. So 1 times 8 is simply 8. For the second observation, x is equal to 10, while y equal 4. So 10 times 4 is 40, etc. And the total of xy is 188. So these are the needed calculations in order to adopt the first formula, which is r equal n summation of xy minus summation x times summation of y divided by the root square of n summation of x square minus x summation of x all square, and this is multiplied by n summation of y square now minus summation of all y squared. So this is the first formula. Of course, if you have a program, it is better to use this formula, same like using the Excel. By Excel, you can do all these calculations simply. So n, which is the number of observations, it's equal to 7. Summation of xy is 188 minus summation of x, which is 36, times summation of y, which is 44, divided by root square of n, 7, summation of x squared, which is 256, minus the summation of x, which is 36, all squared. All of these is multiplied by n summation y squared. This is n. This is summation of y squared minus summation of y all squared. So if you proceed, you will get the value of the Pearson correlation coefficient, which is minus 0.94. So the interpretation for this value of correlation, it is a negative correlation and it is a strong correlation. So it is simply strong negative relationship between the two variables. Let's use the second formula to calculate for the correlation coefficient, small r. Of course, these calculations depends on the calculation of x bar and y bar. So we should first compute the mean for both x and y by dividing the sum for each by the number of observations, which is 7. So the mean for the first variable x is 5.14, while for the second variable y it is 6.29. Now we subtract the mean for the variable x from each value of x and take the sum up. So this is the new column for x minus x bar. For the first observation, here the value of x is simply 1, while the mean or the average is 5.14. So 1 minus 5.14, we get minus 4.14. Same like for the rest, and this is the total. Then we square the calculated value of x minus x bar and take the sum up. So this column contains the square of x minus x bar. So for the first observation, the square is 17.14 and the sum up is 70.86. The same we should did for the other variable or the second variable y. First we need to compute y minus y bar and take the sum up. So this is y minus y bar. For example, for the first observation, y is equal to 8, while the mean for y is 6.29. So 8 minus 6.29 is simply 1.71. The same way for the rest, and this is the sum up or the total. Then we square all or each of these values and sum up. So we should add a new column for y minus y bar all squared. This is the square for the first observation and the same for the rest. And this is the total of the y minus y bar all squared. Finally, we should compute for the multiplication between x minus x bar and y minus y bar and take the sum up. So for the first observation, x minus x bar is minus 4.14, while y minus y bar is simply 1.71. So the multiplication for these two values is simply minus 7.08. Same like for the rest, and this is the sum up for x minus x bar times y minus y bar. So these are all the needed calculations for the using of the second formula. Now we can simply apply for the second formula R, which is simply summation of x minus x bar times y minus y bar, and simply this value is 38.29 divided by root square of summation of x minus x bar square, which is simply this value 70.86 multiplied by summation of y minus y bar squared, which is this value, which is 23.43. So now we can substitute for all of these values in the formula. This is the numerator, which is the summation of x minus x bar times y minus y bar. This is the value here divided by the root square of this value is 70.86 times the second value here is 23.43. If you proceed, you will get the same result. So this is the Pearson correlation coefficient. It is about minus 0.94. So we have the same result. So we have strong and negative relationship between the two variables. So these are the steps that we should use in order to calculate for the Pearson correlation coefficient, small r. Let's do and solve for this question. Sometimes the relationship between the two variables x and y is not a linear shape. So we have, let's say, a curve correlation or a curve relationship between the two variables. So let's understand what happened in this case if we try to compute the correlation coefficient for these data. So we have here these data, we have 9 observations and we have both x and y. This is the figure of the scatter plot for the 9 observations. As you see here, the relationship between the two variables is not a linear relationship. It is curve relationship. So what will happen in this case if we try to count or compute for the correlation coefficient? Let's use the first formula by the benefit of using the Excel. So these are the needed columns and these are the sum up for all of these. This is the first formula. We have n here, 9 observation. Summation of xy is 720 minus summation of x is 108 multiplied by summation of y, which is 60, divided by root square. This is n. This is summation of x square. This is the summation of x. We take the square. All of these is multiplied by, this is n. This is summation of y square. And 60 is the summation of y. We square it and multiply by the first value. So we get a value of r to be 0. So in this case, as our understanding for the value of the Pearson correlation coefficient, 0 states that we have no relationship. Of course, here the relationship is simply exist. Let's return back to the scatter plot. As you see here, if we try to understand the relationship between these 5 points or observation, we see that we have here a negative, somehow strong correlation. While if we take these 5 observations, in this case we have a positive, strong correlation. So the calculated value of the correlation coefficient becomes 0, simply because we don't have a linear relationship between the two variables. We have a curve relationship. So this is why we get a value of r. So we have no relationship, of course, because of the non-linearity between the two variables, which means in general we can conclude that r does not describe the curved relationships. So before starting the computation of the correlation coefficient, we should understand the type of correlation or the direction of the correlation, and it should be a linear shape. That's all for the calculation of the Pearson correlation coefficient. kindly click the like button and don't miss to subscribe to the channel. Thank you and goodbye.